Is blindness a barrier? No.
Is deafness a barrier? No.
Are mobility, learning, cognitive disabilities, speech impairments and others, or even a combination of them, barriers? No way. Lack of accessibility is.
Welcome to Web Accessibility for All.
Follow the blind. This journey starts now.
Hello, my friend. Welcome back to Web Accessibility for All, the podcast that takes the mystery out of web accessibility, making it approachable for everyone. I am Ariel, your host, and today we are continuing with part 2 of our series on building an accessible wizard. In the first episode, we explored the basics of creating an accessible multi-step form, focusing on the pizza wizard component. We designed a simple structure with navigation, step indicator, and screen reader friendly labels to ensure everyone could interact with it. Today we'll go even further. We'll cover focus management and validation logic. Plus, we'll polish everything with accessible styling and test it with a screen reader to ensure our app truly works for everyone. But before we dive into the code, let's discuss why focus management and validation are crucial for accessibility.
Focus management. Why it's non-negotiable.
In a multi-step process like a wizard, focus management isn't just a nice to have, it's critical for accessibility. Imagine navigating the wizard with a keyboard or screen reader. Without proper focus handling, users might lose their place when moving between steps, leading to frustration. Focus management ensures users stay oriented, directly addressing WCAG success criterion 2.4.3,
Focus order,
which mandates logical navigation, and 2.4.7,
focus visible,
which requires a visible focus indicator for all interactive elements. For our pizza wizard, focus will move programmatically to the relevant content.
Form validation, ensuring completeness.
Validation is a crucial tool in creating a seamless user experience. It ensures users understand what actions are required to proceed. Imagine trying to move forward in our pizza wizard without selecting a pizza size or toppings. These are clear issues the system must highlight to guide users towards completion. From an accessibility perspective, this goes beyond convenience. It's essential. WCAG success criterion 3.3.1
error identification,
ensures that when errors occur, they are identified and communicated effectively. Criterion 3.3.3
error suggestion,
takes it further by recommending helpful fixes. Together, these principles prevent users from feeling lost or excluded, especially those using assistive technologies.
Changing the original implementation.
Let's review the necessary code changes for proper focus management and validation in our pizza wizard component.
1. Focus on current step header.
First, let's assign each step header a ref and a tab index of -1. Also, we are going to use the use effect hook to manage focus between steps.
Const step headers ref equals use ref left paren, left brace right paren, semi blank. Use effect left paren, right paren, equals greater left brace. Step headers ref dot current left bracket. Grav step dash dollar left brace current step right brace grav. Right bracket dot focus left paren, semi. Right brace, left bracket current step right bracket right paren, semi.
With these changes, whenever the current step changes, the focus is automatically moved to the relevant step header.
2. Error management and focus.
Now let's change the handle next function to fire the validation before moving to the next step.
Const handle next equals left paren, right paren, equals greater left brace. Slash star. Star moves to the next step if validation passes. Star otherwise, sets focus on the first invalid field. Star slash blank. Const step errors equals validate step left paren, current step, form data right paren, semi. Blank. If left paren, object.keys left paren, step errors right paren, dot length greater 0 right paren, left brace. Set errors left paren, step errors right paren, semi. Blank. Slash move focus to the first invalid field. Const first error field equals object.keys left paren, step errors right paren, left bracket 0 right bracket semi. Refs dot current left bracket first error field right bracket dot focus left paren, right paren, semi. Return semi. Right brace. Blank. Set errors left paren, left brace right paren, semi. Set current step left paren, current step +1 right paren, semi. Right brace semi.
The handle next function now validates the current step. If there are errors, it sets them in state and moves the focus to the first problematic field using the refs. This is critical for accessibility because it directly addresses invalid inputs and guides the user to fix them, making the process less frustrating.
3. Error container at the top.
Let's add a new error container component to display validation messages. We'll code it shortly, but for now, just add it to the top of the wizard.
Less error container. Errors equals left brace errors right brace slash greater.
4. Form state validation logic.
The validate step function is added to enforce specific rules for each step. For instance, step 1 requires a size selection, and step 2 needs at least one topping. Now let's add some logic to validate the state of the selections before moving to the next step.
Const validate step equals left paren, step, data right paren, equals greater left brace. Const new errors equals left brace right brace semi. If left paren, step equals 1 and data dot size right paren. New errors dot size equals please select a pizza size. Semi. If left paren, step equals 2 and data dot toppings dot length equals 0 right paren. New errors dot toppings equals please choose at least one topping. Semi. Return new errors semi. Right brace semi.
This avoids unnecessary navigation to subsequent steps if required inputs are missing. It's all about reducing the effort for users, particularly those navigating with assistive technologies or keyboard.
Why not just let users move ahead and figure out their mistakes later?
Because that's how frustration is born. Imagine ordering a pizza and finding out too late you didn't choose any toppings.
Exactly. Accessible wizards remove friction, making the process intuitive from beginning to end.
Error message component.
We'll create a separate error container component that will handle displaying the validation error in an accessible manner.
Const error container equals errors equals greater. Const error messages equals object.values errors blank. If error messages dot length equals 0, return null blank. Return less div. ID equals error container. Role equals alert greater. Less all greater. Error messages dot map message index equals greater. Less lee. Key equals index greater. Message less slash lee greater. Less slash all greater. Less slash div greater.
If there are errors, it creates a div element and assigns it a role of alert. This is an important detail because the role alert tells screen readers that the content inside the container should be announced immediately, making it accessible for users who rely on assistive technologies.
So, how do we know the user even sees these error messages?
That's a great question. We've got the alert message for screen reader users as well, and the visual styling ensures users see it, too. It's all about multiple cues.
Now, just let's add this error message element ID to our step field set using ARIA described by attribute.
Less field set. Class name equals step. ARIA described b equals error container greater.
This way, screen reader users will be alerted to any errors within the group whenever they navigate to it. Sighted users will see this error displayed above the field set. Validation, when done right, ensures everyone gets the support they need to engage confidently with your app. You might ask, do we really need that step component? The field set can tell the user everything they need to know about the whole group. We don't have to put those messages on every single checkbox or radio button. We could even use other ARIA attributes like ARIA invalid to show when no radio button is picked, or ARIA required to say that something is required. Anyway, I think we made a good start on making our wizard more accessible.
Styling for accessibility.
Accessibility styling is about more than making things look good. It ensures functionality is clear. Buttons should have sufficient contrast. Focus indicators should be highly visible, and error messages must stand out.
Focus visibility.
The focus outlines for inputs and buttons improve navigation for keyboard users, meeting WCAG guidelines for interactive elements.
Error feedback.
The error container styling ensures that errors are clearly distinguishable, aligning with WCAG criteria for error prevention and recovery.
Responsive design.
By using relative units and media-responsive techniques, the design is accessible across devices, improving usability for mobile users.
High contrast.
Strong color contrasts throughout the UI help users with low vision distinguish between elements easily.
Testing the wizard with a screen reader.
Now let's test our app using a screen reader. We're going to use NVDA and Firefox.
Create your dream pizza, an accessible wizard implementation Mozilla Firefox.
Testing steps.
1. Navigate through the wizard using the tab key. Ensure focus moves logically and visually.
Create your dream pizza, an accessible wizard implementation document. Main landmark. Heading level 1. Design your dream pizza, a delicious pizza illustration. Choose your pizza size grouping. Step 1, choose pizza size. Heading level 2. Small radio button not checked, 1 of 3. Next button.
2. Skip required fields and confirm error messages are announced via the alert message. Also verify that the focus moves to the form control group automatically.
Choose pizza size. Heading level 2. Small radio button not checked, 1 of 3. Next button. Alert. Choose your pizza size grouping. Required invalid entry bullet. Please select a pizza size. Small radio button not checked, 1 of 3.
3. Correct errors and verify state persistence when moving between steps.
Next button. Choose your pizza size grouping. Required invalid entry bullet. Please select a pizza size. Small radio button not checked, 1 of 3. Medium radio button checked, 2 of 3. Large radio button checked, 3 of 3. Next button. Select your toppings grouping. Step 2, choose toppings. Heading level 2. Clickable pepperoni checkbox not checked. Clickable mushrooms checkbox not checked. Checked. Back button. Choose your pizza size grouping. Step 1, choose pizza size. Heading level 2. Large radio button checked, 3 of 3. Next button. Select your toppings grouping. Step 2, choose toppings. Heading level 2. Clickable pepperoni checkbox not checked. Clickable mushrooms checkbox checked. Not checked. Back button. Next button. Alert. Select your toppings grouping. Clickable pepperoni checkbox not checked. Clickable mushrooms checkbox not checked. Checked. Back button. Next button. Review your pizza grouping. Step 3, add special requests. Heading level 2. Back button. Submit button.
Congratulations! We've built an accessible wizard. Users of all abilities can navigate confidently. Yes, these changes make the pizza wizard much more user-friendly, especially for keyboard and screen reader users, by guiding focus and providing meaningful feedback. The app became intuitive, inclusive, and frustration-free for all users. Remember, the full code is available in GitHub for you to explore and test further. Thank you for joining this 2-part series, and keep coding with accessibility in mind. Goodbye.
Thanks for joining us today. Subscribe for a new challenge next week. And don't be shy. Leave us a review or ask your accessibility questions online. See you next week for another episode of Web Accessibility for All.